Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our first lesson on the topic of chemistry. In this exciting unit, you will learn many interesting facts about the composition and reactions of matter. Today's lesson will focus on Dalton's atomic theory, which will lead our study on one of the fundamental building blocks of all matter in the universe, the atom. I am anxious to begin, so let us get started. Students, let us ask ourselves, what is chemistry? In your own words, can you define it? Please take a few minutes to think about this. When you are ready, write your definition down on a piece of paper.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had many ideas as to what the word chemistry could mean. You may have said that chemistry is the study of chemicals, which is not entirely true. You might have also said that chemistry is the study of reactions, which is also only partially true. Chemistry is in fact defined as the science which studies the composition, structure, properties, and reactions of matter, especially of atomic and molecular systems. The study of chemistry began about 2,000 years ago. Greek philosophers developed a theory of matter that was not based on the evidence that had been previously collected through experimentation. A philosopher named Democritus was the first to state the theory that all matter was composed of very tiny, indivisible particles. Democritus called these particles atomos, meaning indivisible. This suggested that they were an unbreakable component of matter. Another Greek philosopher, named Aristotle, later investigated this theory. It was Aristotle's belief that atomos did not exist, and he instead believed that all matter was continuous. In other words, his theory suggested we could divide matter infinitely. It was nearly 200 years before anyone challenged Aristotle's theory of matter. While his theories showed strong reasoning, there was little experimentation to suggest his theories were correct. John Dalton developed the first theory that applied scientific experimentation to the study of matter in 1803. While Dalton's theories did borrow ideas from the Greek philosophers before him, his reasoning was the basis for a new era of study in atomic theory. In 1804, Dalton proposed the existence of the atom and proposed the atomic theory, which was based on the ideas of elements and compounds, which we will discuss in a later lesson. Dalton based his theory on the 3 laws of chemical combination. The first law is called the law of conservation of mass. It states that matter is neither created nor destroyed. This means that a mass of reactants and a mass of products are equal in any chemical reaction. Therefore, any chemical reaction only involves the separation or union of atoms. The second law is called the law of definite proportions. This law states that a pure compound is always composed of the same elements combined in a definite ratio by mass. Water, for instance, is made up of the same proportions of hydrogen and oxygen at all times. The third law of chemical combination is named the law of multiple proportions. This law states that when two different compounds are formed of the same elements, the masses of one of the elements in the two compounds compared to the given mass of the other element is in a small whole number ratio. The laws of chemical combination can only be true if we acknowledge the existence of the atom. Atoms are considered as the smallest fundamental part of an element. From his research, Dalton was able to state his theories in what we call the postulates of Dalton's atomic theory. The postulates are as follows. All elements are made up of small particles called atoms. Atoms are indivisible and indestructible. All atoms of a given element are identical in mass and all other properties. Atoms are neither created nor destroyed during chemical reactions. Compounds are formed when atoms of more than one element combine. Lastly, in a given compound, the relative number and types of atoms are constant. Students, this is a classical view of atomic theory. Of these postulates, some have already been disproven by modern theories. On this list, there are some postulates which have been disproven. Do you know which postulates are? Can you think of examples that prove them wrong? Discuss the question with a classmate. Then, take a few minutes to write your answers down.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you concluded that they are postulates 2 and 3 that have been disproven, you are correct. A dramatic example that disproves postulate 2 would be an atomic bomb, where atoms are split to release tremendous force. The existence of atoms of the same element with different masses proves the third postulate was wrong. If you found the disproven postulates and were able to provide an example, excellent work. This concludes our first lesson in chemistry on the structure of the atom. Today, we have learned about the history behind atomic theory by examining the studies by Democritus and Aristotle. We also looked at the first theory to apply scientific experimentation to the study of matter, Dalton's atomic theory. Until next time, thank you, teacher. Thank you, students.